Okay, so just a quick couple notes about this week first and what's happening this week. We're going to do 7-2 day 2 today. Excuse me, 7-3 on day 1 on Tuesday, 7-3 day 2 on Wednesday. Review and do the practice quiz together in class on Thursday, quiz on Friday. So that's where we're headed this week. If anybody knows they are leaving early for vacation, you are? That means your brother is too? No, just you? Okay, when are you leaving? Do you know? Okay, when do you go to study hall? Okay, so here, the practice quiz is on Schoology already. So after I teach you the last thing on Wednesday, I would encourage you to maybe take a look at that Wednesday night. If you're ready Thursday, 6th, 7th period to take that test, I think it would be good to get it out. You don't have to, but I will give that as an option to you.
Okay, I probably will because
yeah, don't have to worry about it over spring break. That's what I would do if I were you. So, all right, anybody else? Okay, another thing that we need to talk about should not apply to a single person in this class, better not. But I need to remind you of our school policy for every high school class that you take. Okay, every high school class that you take, there's the double F rule. Have you guys heard of this before?
Nope.
No? Okay, probably because you guys are in honors classes and most of your teachers don't even bother telling you about it. But, okay, in all of your high school classes, you could be cruising along, getting C's, and then be like, peace out, I hate this class, I'm not doing anything the 4th 9 weeks. I'm done. Because mathematically, I can get an F and I can fail the exam and I'm still going to pass the class. And mathematically, you will pass the class. But the school board says, time out. You're not allowed to just like quit the 4th 9 weeks and do nothing and get an F the 4th 9 weeks and an F on the exam. If you double F, you do not receive credit for the class. Okay, this is called the double F rule. Like I said, a lot of you guys probably have not heard of this because you're in a lot of honors classes and it usually does not apply to children like you. But it is something that you need to know about. Okay, so if you get an F in any high school class, 4th 9 weeks, and fail the semester exam, you can lose credit for the class. So just keep that in mind as you guys progress through the 4th 9 weeks. All right, any questions on the homework from last night? By the way, what shape did this graph make? What was the name of these shapes? Do you guys remember? It starts with an H. Hyperbola. Very good. Okay. Or hyperbole if you have more than one. Okay. So it is a hyperbola. Okay. Let's review the parent function. 1 over x. Where are my asymptotes? On the x-axis and on the y-axis. And then I have 2 branches that would be here and here. Okay? And then as we shift things left, right, up, down, it affects my asymptotes. And if you reflect it over the x-axis, as in 13 and 15, it moves from 1st and 3rd to 1 and 4. I mean, 2nd and 4. All right. How'd you guys do? Any questions on any of these? Okay. Pass the blue papers in. So I need, Caleb and Quinn, Laura, Josh, and then whatever you guys just combine those, get them all collected for me. Let me pass these out, then I'll be back.
That is like you're the one who took it.
All right. All right.
I would say
Jared, this one absent. Okay, so let's look up front. We are going to talk about day 2. We're going to talk about a couple more important pieces of graphing quadratics. So, not quadratics, rational functions. If it's in this form, you can clearly see which way the hyperbola has shifted. And then you can clearly see where your asymptote has shifted. But if I give it to you in, as you see, this form, it's not easy to see if it went left, right, up, down. You can't tell. So we have some rules. If it's in ax plus b over cx plus d, okay, if it's in this form, the vertical asymptote, guys, think about this once. This one shifted which way on 11?
Right one.
Right one. So where was my vertical asymptote? It went what?
Right one.
This one. Which way did it shift? Left 2. So where was my vertical asymptote? Left 2. Notice in both of these cases, that is the value that makes your denominator 0. So the vertical asymptote is always found by what is the value that makes the denominator 0. Now they give you this big formula because what did they do? They took this, they said what makes that 0? Well, how would you guys solve this for x? You would subtract d and then you would divide by c. Okay, I'm not going to have you memorize that formula. I'm going to have you memorize that the vertical asymptote is where the denominator is 0. That's what you need to know. The vertical asymptote is where the denominator is 0. Okay? Because you can just look at it usually and figure it out. Now, the horizontal asymptote, if the degrees are the same, which they will be in our class, so notice you just have a degree of 1, they will always be the same. When that happens, it's leading coefficient over leading coefficient. Done. The horizontal asymptote. So the horizontal asymptote is y equals, because it has to cross the y-axis, and then it's leading coefficient over leading coefficient. All right, so let's take a look at this first problem. Graph, find the domain and range, and I would like you guys to add to this, please, to find the equations of the horizontal and vertical asymptotes. Find the equations of the horizontal and vertical asymptotes. I'll give you a minute to get that written down. Okay, so I think we need to do that first. I find the equations of the vertical and horizontal asymptotes first. Where does the vertical asymptote occur? It occurs where what? The denominator is 0. So what would make the denominator 0? Well, most of you know it's what? At 3. Now, you could set this equal to 0, add 3, and it's at x equals 3. Okay? Most of you knew it was x equals 3 without me showing any work. So, it crosses the x-axis at 3. So you come out here and you dash that line. Now, the horizontal asymptote. The horizontal asymptote is at y equals, and then it's leading coefficient over leading coefficient. So what's the leading coefficient of the numerator? 2. What's the leading coefficient of the denominator? So it's just at y equals 2. So crosses the y-axis at 2. Now, when I make my table of values, I am going to pick 3 points to the left of the vertical asymptote and 3 points to the right. So I'm going to pick, let's see, that's at 3. So I'm going to pick 2, 1, 0. Okay, then I have my asymptote, and then I'm going to pick 4, 5, 6. So there's my asymptote. Now when you plug in 0, okay, what's 2 times 0? 0 plus 1? 1. And what's 0 minus 3? Negative 3. So you have negative 1/3. Plug in 1. What's 2 times 1? Plus 1? 3. So I have 3 over, plug in 1, negative 2. So 3 over negative 2. Negative 3/2 or negative 1.5. Okay. How about 2? What's 2 times 2? 4 plus 1? 5. And then when you plug in 2 here, what's 2 minus 3? So that gives you what? Negative 5. Now, if you are calculator dependent and you want to do this in your calculator, you must, when you type this into your calculator, have the numerator in parentheses divided by the denominator, unless you have math type. My plot is turned off. And I'm going to do zoom 6. So I'm going to finish my chart here. Okay. Now I'm going to go second table. And it's important to know where your axes are so you can say, okay, yeah, at negative 1, I have at 0, I have negative 1/3. At 1, I have negative 1.5. At 2, I have negative 5. At 3, there's my asymptote. Okay. And then you can see the rest there. At 4, you have 9. At 5, you have 5.5. And at 6, you have 4 1/3. Please don't use your calculator to find the asymptotes only. It'll kill you when we get to some of the solving stuff. All right, so I'm going to go over 0, down 1/3. Over 1, down 1.5. Over 2, down 5. Now, this is where you always hear me say go from asymptote to asymptote. What do I mean by that? I have kids who do this, and this is wrong because to me, that looks like, this is wrong. To me, this looks like the asymptote's at the x-axis. Is the asymptote at the x-axis? No. So you're going to go from asymptote through those points to that asymptote. And now I'm going to go over 4, up 9, over 5, up 5.5, over 6, up 4 1/4, and again, asymptote through the points down to that asymptote. Be neat about your graphs. Okay, graph paper is a fantastic thing because you should have tick marks on your paper if you don't have graph marks or graphing paper. Domain and range. The domain, X is allowed to be everything except what? Some of you forgot this on your homework last night. What's the domain? Everything except what? 3. What's the range? Y is everything except what?
2.
2. We're going to skip B, so if you're working ahead of me, we're skipping B. Are you guys good on A? Okay, we're skipping B. Going to C. All right. Vertical asymptote. What makes the denominator 0? Careful. Set this equal to 0. And now if you add the x over, what do you guys get? It's at -1. So the vertical asymptote is here at -1. How do you find the horizontal asymptote? Coefficient divided by y equals leading coefficient over leading coefficient. What's the leading coefficient in the numerator? -3. Denominator? So this is just y equals +3. Yep. So up here, y equals 3. Okay. Use your graphing calculator. -3x. Guys, please do the asymptotes before you go to your graphing calculator. It'll help you. Graph. Table. Now we know the asymptote's at -1, so I'm going to pick 3 to the left and 3 to the right. So at -4, I'm going up 4 2/3. At -3, I'm going up 5 1/2. And at -2, I'm going up 8. Again, asymptote to asymptote. Then at 0, I'm going down 2. At 1, I'm going up 1/2. And at 2, I'm going up 1 1/3. Asymptote to asymptote. All right, domain and range. What's a domain? X is not allowed to be what? -1. Range. Y is not allowed to be what? 3. Guys, please don't rely on your calculator for your asymptotes. Okay. Questions on first example? Are we cool with these? All right, well, what if we want to take a function that's given to us in this form and make it look like this form? So we can clearly see which way we've shifted, left, right, up, down. All right? Well, what's another way to read this function? 2x minus 4 over x minus 5. What's another way to say over? Divided by. So one of the things we can do is we can use division to divide 3x plus 5 by x plus 1 and rewrite it in this form. Because the first thing it says is rewrite. And you will be required to do this on your quiz on Friday. Rewrite. Okay, so what does this one say? This says 3x plus 5 divided by x plus 1. Oh, man. I promise you these are easy long divisions. Some of you are like, oh my gosh, Mrs. Apples. Okay, what do you guys multiply x by to get to 3x? 3. Now, what do you do with the 3? Distribute, and when you distribute, what do you guys get? 3x plus 3. And now what do? We come in and we subtract. So we change both signs. When I do, what do you guys have? Well, these cancel and you're left with what? 2. Okay, does this, the degree of the 2 is less than the degree of the divisor, so we're done. Now think about how we wrote your answer. This is where people screw this up. Okay, what is the answer? 3 plus a remainder of what? 2 over, or g of x equals, does it matter what order I add? So I'm going to flip-flop these. 2 over x plus 1 plus 3. Now, I will tell you what you guys do is you switch the 2 and the 3. You switch the 2 and the 3. That's okay. Big mistake. The answer is 3. The remainder goes over the divisor. So I always start with this 3 plus my remainder over my divisor, then flip it. Okay. Now that we're looking at this, describe the transformations. All right. What's the 2 going to make it do? It's going to have a little what? Stretch, and I'm okay with just stretch right now. What's the +1 going to make it do? This is the important part. Left 1 and what? Up 3. Those are the ones I'm really, the number that's in the numerator doesn't, it's the left 1 and the up 3 that really affect things, because now what happened to my asymptote? It went what? Left 1, and my horizontal 1 went now. When you enter this, you can enter it either way. Actually, it might be a good way to see if you got it right. Right? I could enter parenthesis 3x plus 5 divided by parenthesis x plus 1. Or I could divide 2 divided by x plus 1. Close your parentheses, add 3. If I graph both of these, what should happen? If I did this right, they should be what? On top of each other. All right, graph. All right. Do I have only one graph? Now, how do I know? If you go to trace, okay, see how I go to trace and I can move along this graph? Notice up here it says Y1. If I hit the up arrow key, I'm on Y2. Okay, do you guys see that? And you have different colors. So if you guys go up and down, yours changes colors. Which is really cool. All right. So now I'm going to go to my table. Now, these should be the same. Why should they be the same? Because they're the same graph, right? Okay. Pull that off. So at -4, I have 2 1/3. At -3, I have -2. At -2, I have positive 1. Sorry, positive. And here's my graph there. At 0, I have 5. At 1, I have 4. And at 2, I have 3 2/3. Again, asymptote through the points, asymptote. Did I answer everything they wanted? Let's see. I rewrote it. Do that. I graphed the function, and I described the transformations. Please make sure you answer all the questions tonight. Some of you only graphed them. So make sure you answer all the questions tonight. All right, next one. What are we going to divide? What by what? 2x minus 4 divided by? Okay. How many times does x go into 2x? Twice. Multiply, you get what? 2x minus 10. Okay, now when you change it's not -14, because what do you have to do? Change your signs. What's your remainder? 6. Okay, so how do I write my answer? My answer is 2 plus a remainder of what? 6 over x minus 5. Or, in the correct form, 6 over x minus 5 plus 2. What transformations happen to this graph? We're not worried about the stretch. Which one? Right 5 and right 5. up 2. So draw your asymptotes in. Right 5, up 2.
You don't have one.
Now I'm just going to put this 1 in. I had 6 divided by x minus 5 plus 2. Graph. And I'm going to go to my table. And I got to go way up to 5 to find that asymptote. At 2, you got 0. At 3, I'm sorry, I did that at 3. At 2, you have 0. At 3, you have -1. At 4, you have -4. At 6, you have 8. At 7, you have 5. And at 8, you have 4. Asymptote through the points to asymptote. Same thing here. Make sure you go all the way over to those asymptotes. Did I answer all the questions? Did I rewrite it? Describe the transformations and graph. Okay.
You did it wrong, bro. You did it wrong.
You play baseball too? All right. Homework.